Hey everyone. All right, so I just wanted to go over the review that I assigned for this quiz coming up on Thursday. And remember, this is a YouTube link, so go ahead and flip through and rewind and skip forward to any problem that you might have struggled with that you want to see in a little bit more detail. All right, so let's start with the first three problems. So on the first three problems, all you guys have to do is looking at the function, state whether it's exponential growth or an exponential decay. So when we look at problems like number one, remember, anytime that we're looking at a normal exponential function, you just look at the base number. And if that base number is in between 0 and 1, that means that this would be a decay function. If we look at number two, do the same exact thing. All right, you're looking at your base number. Now, I know it looks like there is a negative in front of that 4, but you're really just focused on that 4 by itself. Remember, that negative just tells you that you're flipping underneath your horizontal asymptote, but your base number in this case is just that 4. So in this case, since 4 is larger than 1, this would represent an exponential growth. All right, last one when you're identifying. If you guys look at functions with e, remember, you're not looking at the base number like we did for 1 and 2. E's are a little bit different. You have to look at the number that's what is in front of x in your exponent. If that number is a positive number, like this one is, that's when you're also going to have growth. If that number was negative for e, that's when you're going to have decay. All right, but number 1 is decay, number 2 is growth, and number 3 is also growth. All right, so let's go through and actually start graphing some of these things. So the first 6 that we're going to start out graphing are just normal exponential functions, not involving that Euler's number, not involving e. Okay, so remember, when we graph these, if we look at number 4, the first thing that we always want to do is plot the horizontal asymptote. And since there's no big plus or minus at the end, our horizontal asymptote in this case is just going to be right along our x-axis. Next, we're going to look at our base number and think about whether that base number is positive or negative. Since this base number is just a 3 and it's a positive, that means that we're going up 1 from that horizontal asymptote. And we're not shifting left or right any, because if we look with our x and our exponent, there's no plus or minus number there. So I'm just going from my horizontal asymptote, I'm going up 1 and plotting that first point because the 3 is positive. All right, now we have to plot our second point. So plotting our second point, we're going to go back to our horizontal asymptote, but now we're really going to focus on our base number. Since we see that base number being a 3, from the horizontal dotted line, we're going to jump up 3 units and then run to the right 1. And we always run to the right. That's going to give us our 2 points. We just connect these 2 points, forming that line that starts to go up as you go to the right. All right, let's look at number 5. So for number 5, first thing, plot your horizontal asymptote. So since you see a -2 at the end, that means my horizontal asymptote is just going to be going down 2, which is just through -2. All right, next thing you want to do is you want to get your first point. And you know what? Even before you do that, if you want to say whether this is a growth or decay, to kind of visualize what you're going to end up graphing, this is a decay type of graph because our base number is 2/5. Okay, sorry, going back. All right, so now what we want to do now is graph our first point. Since that 2/5 is, again, positive, that means that, just like last problem, we're going to go up 1 unit from the horizontal asymptote. There's no shift left or right, so I'm just going up 1 and putting that first point. Now I'm going to take a look at my base number of 2/5. Since that 2/5, or what that 2/5 really tells me, is from my horizontal asymptote, I have to go up 2/5 and then to the right 1. Just like I always say, guys, it's not going to be perfect. As long as it's somewhere in between -1 and -2, that's okay. And then we know that this is going to be a decay graph, so it should face down as we go from left to right and then trail that horizontal asymptote, which it does. All right, let's look at number 6. So I'll actually start with this time. All right, on number 6, first thing, think about whether it's going to look like growth or decay. Looking at your base number being a 2, you know that this graph has to look like a growth function. Now that we have that, we know a horizontal asymptote is a positive 1, so that means we're going to go up 1, and that's going to be a horizontal dotted line. The next thing we want to do is plot that first point. Since my base number is a positive 2, that tells us that we are going to go again up 1. Now be careful. This is the first time in this review that we've seen a shift left or right. And remember, h is always opposite. So yes, I am going up 1 because my base is 2. But then since that's an x minus 2, remember that tells us that the opposite of it. So we actually have to go to the right 2. So I do go up 1, but I have to go to the right 2. All right, now using my base number of 2, we have to get our second point. So I'm going to start at the horizontal asymptote, but I'm going to start directly below that first point we just made. From there, I'm going to hop up 2 units, and we always run to the right. So I go up 2 and to the right 1, and there's my second point. So then I connect those 2 points, and it looks like our growth shape. All right, let's keep going with this stuff. All right, let's go to problem number 7. So on number 7, same thing first. Think about to yourself whether this is going to be a growth or decay looking shape. Since there's a 1/2 as our base number, we know this has to be decay. All right, so the first thing we're going to do is we're going to plot our horizontal asymptote, which is all the way at the very end. So that tells us we're going to go down 1, and that's going to be where our horizontal dotted line lies. Now, my base number is a 1/2, but because I look out in front and I see that negative in front of that parentheses, now that tells me that I'm going to go down 1 unit. So I am going to go down 1, but again, be careful. We do have a shift. So I am going to go down 1, and in this case, I'm going to also go to the right 1 because of that x minus 1. And we always do the opposite, just like we talked about on problem number 6. All right, so now that I have my first point, let's try to get our second point. So using my base number of a 1/2, I'm going to go back to my horizontal asymptote. I'm going to go down a 1/2 unit, and then I run to the right. Again, I'm going down because it's a negative out in front. That's going to form my 2 points, create my graph. That looks like that. And again, that is a decay. It just is on the bottom of our horizontal asymptote. All right, let's look at 8. So on 8, first thing, if you guys look at that 1/4 being your base number, you know that this is going to be a decay graph. All right, after we identify it being decay, let's identify our horizontal asymptote. There's nothing all the way at the very end, so the horizontal asymptote is going to go right along your x-axis. My base number has a positive out in front of it. So since it's a positive, that tells me I'm going to go up 1. But again, be careful about that shift. Since there's a +3 with x, that means I have to go to the left 3. So I am going up because my base is positive, but then I have to go to the left 3, and that's where my first point's going to lie. Now I'm going to use my base number of a 1/4. So from my horizontal asymptote, directly below that first point that I made, I'm going to go up a 1/4 and run to the right. I'm going to connect those 2 points. Sorry, I know it's not connected, but it should be. Kind of hard to do with my finger. But I connect those 2 points, and that forms that decay function. All right, number 9. Same thing. First thing is we want to visualize whether this growth or decay. And in this case, if I'm looking at my base number, just like we talked about with problem number 2, I know this does have a negative out in front of it, but I'm really just focused on the 4. And since we know 4 is bigger than 1, I know this should look like a growth when I go ahead and plot this thing. So the first thing I want to plot is my horizontal asymptote, which is that number at the very end. And that sign stays the same like we've been doing. So that tells me that I'm going up 3 and putting that horizontal dotted line through 3. Now, when I look at my base number and I see that negative in front of 4, that tells me that this should lie below my horizontal asymptote. So from my horizontal asymptote, I'm going to go down 1. Now, this graph doesn't have any shifts left or right. So once you go down 1, you're safe to put that first point there. All right, once you have that first point, now let's look back at our base number. And again, we're looking at this whole -4. So now from my horizontal asymptote, directly above that first point that we just made, I'm going to now count down 4 units, and I'm still running to the right. So those are my 2 points. I start out close to my asymptote, but as I go to my right, this starts to go downwards to infinity. So it looks like that. Just make sure, guys, when you are graphing these, that none of these graphs should ever cross the horizontal asymptote that you are creating. They should all be everything above it or everything below it, but never crossing. Again, you know it's above if the base is positive. You know it's below if your base is negative. All right, so the last 3 that we're going to talk about actually involve using that Euler's number E, which is the last thing that we just left off with before this review. Okay. All right, so if you guys remember with E's, we started to use T-charts instead to help us out, and we also had to use a calculator. So yes, you guys will be able to use a calculator for this quiz coming up tomorrow. Or I should, yeah. Okay. All right. So first thing on number 10, if you want to, I think it'll be helpful too, is think about whether this is going to be a growth or decay. Now, I'm not looking at the 0.6 anymore, like that doesn't matter. Where I'm looking for all these E's is out in front of X. In this case, since there's really a positive 1 in front of X, I know this should look like a growth when I go ahead and graph it. All right, so, well, first things first, before we even make a T-chart, let's graph our horizontal asymptote, which is the same. We're just looking at that big plus-minus number at the very end. And since there is none, your horizontal asymptote is just going to be 0. All right, so now let's focus on making this T-chart. So I'm going to make this first T-chart in red. So we talked about always using 0 and 1 for our X values. But remember, in order to get your Y values, you're blocking out any shift that's happening. So like that -2 that's with X, think about that not being there for right now. So you're really just thinking about, and I'll erase this in a second, but you're really just thinking about 0.6 times e to the x. That's when you're going to plug 0 and 1 into. Okay. All right, so now when we go to our calculator and we plug this in, well, I guess I should start. The first one, when you plug in 0, 0 is the easiest because e to the 0 power is just 1. So 0.6 times 1 is just going to be 0.6. It's just going to be itself. So that one's not bad. But when you plug in a 1, you are going to have to use your calculator. So when we plug in a 1, I would do 0.6. Hold on. So I would do 0.6 times, and then remember your e can be in this function tab, and then you are going to have to go back and put in an exponent. So in this case, we know we're plugging in the 1, so we're going to have 0.6 times e to the first, which in this case gives us a 1.63. And you can just round to 2 decimal places. So that my y value would then be, again, 1.63. Okay. All right. So after you have that, now we know that we need to make our second T-chart because there is a shift in this graph. So if we go back to our original function and we now kind of uncover what I just scribbled out in red, we know that we have a -2 with that x up top. So remember, that affects your graph left and right, and it's always opposite. So that tells us that we're actually going to move our graph to the right too. So that means that I'm going to add 2 to all of my existing x values. So the 0 is now going to become a 2, and the 1 is now going to become a 3. But my my y values are going to stay the same exact thing. They're not going to change. So I still have a 0.6 and I have a 1.63. So this new T-chart, these are the new ordered pairs that you are now plotting. So that means I'm going to go 2 to the right and up 0.6. And then I'm also going to go 3 to the right and up 1.63. And then we connect our dots. It looks like a growth function, which makes sense because that's what we thought about to start this problem. All right, so it would end up looking like this. Okay, let's look at number 11. All right, so number 11 is really similar. So the first thing you want to think about is whether you have growth or decay. Since in front of your x is technically a +1, even though you don't see it, this should look like a growth graph as well. I don't know why it's not letting me write. All right, there we go. Okay, so this should look like growth. Now, after you identify that, let's go ahead and plot that horizontal asymptote. If I look at the very end and I see a -2, that means my horizontal asymptote is going to go through -2 on your y-axis. All right, now we need to start creating some t-charts to help us get some points. So my first t-chart I'm going to do in red, and we're going to pick 0 and 1 for x just like we did before. Now remember, when you're getting your y values, don't think about your shifts up and down or left and right. So I'm scribbling out the +3 with x and the -2 all the way at the end. So we're really treating this problem when we use this first t-chart as just 1/2 times e to the x. So when we plug in a 0 for x, we just get 1/2 times 1, which gives us 1/2. I'm going to write it as a decimal just to kind of save myself a little bit of room instead of writing a fraction. But you know 0.5 is the same thing as 1/2. Now when you plug in a 1, you're going to have to do a little bit of work on your calculator. So what we want to do is we want to multiply a 1/2 times e to the first. And when we do that, we end up getting a value of 1.36. All right. Okay, so there's your first t-chart. Now, just like last problem, we know we're going to have to make our second one. So when we make our second t-chart with these shifts, we want to uncover those shifts that you made to start the problem. All right. So we know with x, we see a +3, which affects our x values the opposite way. So I'm going to have to subtract a 3 from my x values. Now my y value, since I see a -2, that means I'm also going to subtract a 2 from my existing y values. All right. So for my x values, I'm now going to have -3 and -2. And for my y values, I'm going to have a -1.5. And if you need to do a little bit of work to get this too, you definitely can. Like if we wanted to do 1.36 minus 2 to give us what our new y value should be, we definitely can. It gives us -0.64. So that would be our second y value. All right, and remember, this is going to be the t-chart that you guys are going to use for your ordered pairs. So the first point tells me I'm going to go to the left 3. I'm going to go down 1.5. And then my next point tells me I'm going to go down 2, but going to the left 2 and then going down 0.64. And again, we know this should look like a growth shape, which it does going through those 2 points. All right, last one we're going to look at is number 12. So when you guys look at number 12, first thing you're going to identify is that this is going to be decay. Because we see with x, there's a -0.75. So that negative tells me that this should look like a decay. Next thing we're going to do is we're going to plot our horizontal asymptote. So we're looking all the way at the very end. We see a -3. So we're going to go ahead and make that horizontal asymptote at -3. All right, now let's go through and make our t-chart for this. So I think I'm going to do this on the side. Actually, you know what? No, I'm still going to do it down here. Okay. All right, so let's make our first t-chart. So we're still picking a 0 and 1 for x like we always do, but we're covering up our shifts. So the only shift that you see here is that -3. That -0.75 in front of x is not a shift. That tells you how your graph is going to look. So what we're really working with in this case is 3 times e to the -0.75x. That should be what you guys are plugging 0 and 1 into. Now, when you plug 0 in, it's pretty easy because -0.75 times 0 is just 0, and then e to the 0 is just 1. So then we get 3 times 1, and that ends up just giving us 3. Now, when we plug in a 1, though, that's going to be a little bit more work, and we're going to have to use our calculator. So what we want to do is we want to do 3 times, then we're going to go over to our e button, and e is now raised to a negative 0.75. Now, I know it's times 1, but you don't have to put the times 1 in there because we know that's just going to be negative 0.75. And when we hit enter, we end up getting a value of 1.42. Oh, sorry. Just moved it. Okay. All right, so then my next value would be 1.42. Okay. All right, so let's look at what our new T-chart should be. So if we go to create our new T-chart to get our two ordered pairs that we need to plot, we're going to first uncover the shift that was happening. So we know we had a big -3 at the end, and that affects our Y values by subtracting a 3. So my X values of 0 and 1 are going to stay, but my Y values are now going to become a 0. And then if we do a little bit of work on our calculator too, by doing 1.42 minus 3, we end up getting negative 1.58. So then my other Y value would be negative 1.58. So remember what we said to start that this should look like a decay. So 0, 0 actually falls right at the origin, and then 1, negative 1.58 tells me I go to the right one. I go in between negative 1 and negative 2. And those are my 2 points, and then I connect these 2 points to form this graph. So it definitely makes sense that it's going down as you read this from left to right, because like we said, it should be a decay graph. All right, so if you guys have any questions on any of these 12 problems that we went over, please reach out to me. I'm going to hold a Google Meet session again today. Please join it. But let me know if you guys have any questions. All right, have a good day, guys. I'll see you later.